Starting section 1.2, and in this section here, we are going to talk about some geometry concepts, but we've got, here are two sets of parallel lines. And with that, we get all of these angles that are formed because of the lines being parallel. I'm going to number these angles 1 through 8 so I can reference them. But let's go ahead and fill out this information. So we've got parallel lines cut by a transversal. So we've got parallel. Create 4 sets of angles. We've got the first set here are called alternate. We'll go alternate interior. Let's do that one first. Interior. Now, examples of alternate interior angles would be angles 4 and 6. Angle 4 and angle 6. Alternate interior angles. And what we know about those angles is that they are congruent to each other. They are the same measure. And we have a marking system that we've used, and we'll mark them like 4 and 6 are congruent to each other. Another set is alternate exterior angles. Exterior. An example of a set of alternate exterior angles would be angle, I'm going to go angle 1 and angle 7. Those are alternate exterior, so those are a different measure from angle 4 and 6. But angle 1 and 7 are also going to be congruent to each other. So they are also congruent to each other. And then we've got interior angles on the same side of the transversal. Interior angles on the same side of the transversal. So that would be this angle here, 3 and 6. That's an example of those. What we know about them is that they their measures add to 180 degrees. So let's define that. This line right here is called a transversal. We've got our line that cuts through those parallel lines. That's called a transversal. And then we've got another set here. It's called corresponding angles. And corresponding angles have the same measure. Let's talk about where those are located. Corresponding angles examples would be like angle 2 here, which is congruent to angle 6. So angle 2 and 6. I like to refer to those angles. They're in the same position. So like they're both on the right side of my transversal, angle 2 and 6 are. And I'm referring to these two right here. And they're also both above the parallel lines. So corresponding angles, it's like they're in the same position, same side, both above. And you would have studied these angles in geometry, and we've had to, use their relationships to be able to solve a lot of different problems. All right, so then main thing there is knowing which ones are congruent and which ones are adding to 180. Also, and with these, you've got angles that are across from each other, like angle 6 and 8 right here. Those are vertical angles. They're equal to each other. So we also have vertical angles. Those are also congruent to each other. We've got a lot of angle relationships. Now, in this diagram right here, this big diagram, there's only 2 different measures of angles. They either are equal to each other or they are going to add to 180. We've got this thing called the triangle sum theorem. Triangle sum theorem is that all of the angles add to 180 degrees in a triangle. So as an example, if I had a 30-degree angle and I had a 60-degree angle, then the other one would have to be 90, right? They have to add to 180 degrees. Similar triangles have corresponding angles that are equal, and the corresponding sides are, we call it proportional. Let's say that I've got angle or triangle ABC here. And side across from angle A, we would call little a. Side across from angle B we would call little b. And side across from angle C, we would call little c. That's just like a standard way that we label. And let's call this triangle X and then Y and then Z. And then the same goes for that. So across from X is little x. Across from Y would be little y and Z. Now, if we are looking at these two triangles, I could say that, let's say triangle ABC is similar to triangle X, Y, and Z. So the letters would go in the correct order, and I'm going clockwise when I label their similarity statement. That's what this is called. This is called a similarity statement. Now, with these two similar triangles, we have angles are equal. That was one of the first things that this statement said right here, angles that are equal. So let's talk about that. So angles. So we got congruent angles. There's my abbreviation or my little symbol for angles. So we've got angle A would be congruent to angle X. Again, that means that they're the same measure. Angle B would be congruent to angle Y. And finally, angle C would be congruent to angle Z. Three congruent angles. The size of the shape is what's changing, but the shape is the same. And with that being said, the angles would have to be the same. The other part to this, with these two similar triangles, is that we call it the sides are proportional. Now, this is what that means. So the proportionality sides are proportional, which that's really going to allow us, you would be allowed to find missing measures in two similar triangles because you could write a proportion and solve for missing measures. But we know that starting with a left side triangle, if I start by saying side C is going to be corresponding and compares to side Z, and that ratio would be equal to side A compared to side X. This is our proportionality statement. And third side B is compared to third side little y. And so you can always write proportions with those measures. Now, the proportions can be set up in a lot of different ways, but you are comparing the sides that correspond to each other. So this side C corresponds to side Z. And so then I have, you can see on the top of my proportionality statement, these are all left side triangle. So those are the measures on the top. And then right side triangle are the measures that are on the bottom. But in the past, you have used proportions in order to set up missing parts to any triangle. So a lot of this information on this front page here is informational. It is review from geometry, and we are going to be using this information throughout the course at different times. Let's go ahead and take a look at the second page here, and we'll look at some examples. Now we're going to have to assume some of that information from the first page, so you can refer back to that. It says, given that the lines are parallel, I like to mark things, so we're going to mark parallel lines. Find the measures of angles 1, 2, 3, and 4. So, of course, we don't have those labeled in here, so I'm just going to do this. Angles 1, angles 2, I'll do angle 3 here, and then I'm going to jump down 4 at the bottom. Let's see if we can find all of these measures. also going to see here that this 5x minus 40, that little quantity here, okay, that is going to be, I'm going to put that on this side right here. All right, so it looks like that just got shifted over in the formatting. So here's what we know. We've got, it doesn't matter where I would have put that, we would have been able to find the measures. We've got this angle 1 here on the outside, 3x plus 2. We've got angle 4 here on the outside. Those are alternate exterior angles because one angle's on the left side of the transversal, the other one's on the right side of the transversal. And so if I set them equal to each other, because they're going to be congruent, right? If I set them equal to each other, then we would solve this. It would be 3x plus 2 equals 5x minus 40. I'm going to subtract 3x over here to the right side to keep my x's positive. And that gives me 2 equals 2x minus 40. Add the 40 across, that's 42 is equal to 2x. So x equals 21. So here's what we're going to do with that. We're going to take our 21 and we're going to have to substitute it back in. So if I substitute 21 back in to 3x plus 2, 3 times 21 plus 2, that is 63 plus 2, which is 65 degrees. So here's what we've got. Angle 1 at the top is 65 degrees. That means also angle 3. Angle 1 and angle 3 are congruent to each other because they're vertical angles. So both of these are 65, and that one is 65. We would also know angle 4 is 65. Those are all because of corresponding angles with 3 and 4, and because of alternate exterior angles with 1 and 4. So the only other measure that we have to find is angle 2. But we already know the other angles are 65 degrees. And so let's talk about how to find that last angle. If I know that angle 1 and angle 2 here form that straight line, that means they are a linear pair, and linear pairs are supplementary angles. So then if I take the 180 and I subtract 65, because those two angles would have to add to 180, what I'm going to do is I would subtract those, and you would get, what's that going to be, 115 degrees. So that's the measure of angle 2, 115, 115 here. So what we did is we used the fact that we had parallel lines. We labeled our angles there, and we knew that those two angles that were given to us were equal to each other because of their location. And then you can find all the angles that are in that whole diagram. We didn't have to find the other angles, but you can see that this one would be 115 here. This one would be 65, and we could just keep going on. This one's 115, right? And this one's 115. So we could go and find all 8 angles. All right, let's move on to example 2. Find the missing components of the similar triangles. Always draw a picture. Triangle, let's go ahead and do triangle ABC. It doesn't really matter how I draw it, but when I draw my second triangle, of course, I'm going to put the letters in the correct order. Similar to NMP, in order N, and then M to the top, and then P, because that's how I did my A, B, and C. The measure of angle A is 45. And the measure of angle M is 31. Find the measure of angle C. Okay, so the question is angle C here, and here's what we know. If angle M is 31, then angle B is also 31. I can label that. And I know that that measure of angle A plus measure of angle B plus measure of angle C, that would equal 180 because of the triangle sum theorem. And we already know that A is 45 and B is 31. So then finding the measure of angle C, we'll just have to solve for angle C here. So 45 plus 31 is 76. So if we subtract the 76 over, then measure of angle C would equal 104 degrees. All right, example B. So we've got triangle ABC again. Let's go ahead and draw out our triangle. Is similar to triangle D, F, and E. Again, label your sides so that they are in order, your angles. D, F, E. The measure of AC is 16. A to C is 16 on the bottom. BC is 32 over here on the side. A to B is 24. E to D is 8. And what it's asking us is to find both EF and DF. Now, when we do this, we can only find one of them at a time. We're going to set up our proportions because we know the sides are, there's proportionality statement between the two similar triangles. We are going to start with using 16 and 8. All right, now you can see that the second triangle is half the size of the first triangle, so this actually becomes pretty easy for us to find the two measures, but I'm going to show you how to use proportions. So you would set up your proportions. 16 over 8 would equal, let's find DF first. So then it would be then 24, because that one would correspond to our length of DF. So this 24 here, left side to left side. And then you could cross multiply and divide. So we have 16 times the measure of length DF would equal 8 times 24. And that is 192. And then divide by 16. So the length of DF would equal 12. And then we would do another proportion to find the side of FE. And so you can set up your proportion the same way. We can go 16 over 8 equals, now the side that corresponds to FE would be 32. So 32 over the length from F to E. F to E, E to F. It is the same measurement. So this would be 16 times F to E, that segment length, equals 8 times 32. And that is equal to 256. And then, of course, if we divide by 16, the length from F to E is equal to 16. Now, I just want to show you that comparison in our triangle. So we found F to E to be 16. And we found D to F to be 12. Now look at those measures. The right side triangle, remember, was half the measure. So we started with 16 on the bottom, and it goes to 8, 32, 16, 24 to 12. So everything kind of worked out there. But you can either, obviously, if it's a relationship that you can find out on your own, like just dividing by 2 there, you can do that. But of course, there's ways to write proportions to solve. All right, we've got workers. Morganza Spillway Station needs to measure the height of a station flagpole. They find that the instant when the shadow of a station is 18 feet long, the shadow of the flagpole is 99 feet long. The station is 10 feet high. Okay, so we've got a relationship here where you would draw a triangle, okay? And let's start talking about the station. So here's what we know. The station is 10 feet high. We're going to make that the station right here, 10 feet high. Okay. They need to measure the height of the station flagpole. Let's say here's our station flagpole. We don't know what the height is. We're going to call it X. The shadow, it says they find that at the instant when the shadow of the station is 18 feet long, this shadow is going to be on the ground, 18 feet. That makes a right triangle. We intentionally make a right triangle here so that we can say that they're similar to each other. The reason why they'd be similar to each other is because of the fact that they're measuring the shadow at the same time with the angle of the sun. And then the flagpole is 99 feet long. Okay, this is a bigger triangle. You don't have to draw to scale, but we know it's a right triangle. Okay, everything, we would assume the building's vertical, we would assume the flagpole is vertical. In this case, a little unrealistic with this flagpole being that much higher than this station, I would assume. So, but we set up our proportion. It would be left side 10 over left side x would equal bottom 18 over bottom 99. And then we would cross multiply and solve. So 10 times 99 is 990. And then 18 times x is 18x. We're going to go ahead and take that 990 and we'll divide it by 18. And that measure is 55. So that's our answer. We have 55 feet. That's how tall that flagpole is. All right, our last question here. Find the measure of the angles of a triangle ABC. Let's draw our triangle ABC, and we'll put in whatever measures we need to. So we've got A, B, and C. Measure of angle A is x. Measure of angle B, 2x minus 10. Measure of angle C, 5x plus 30. Here's what we know. The three angles of any triangle add to 180. So we have x plus 2x minus 10 plus 5x plus 30 equals 180. In order for us to find the measures of the angles of this triangle, we have to figure out what x is. On the left side, I have, combining my like terms, I've got x, 2x, 5x, that's 8x. Negative 10 plus 30 is 20, equals 180. So 8x would equal 160. Subtract the 20 over, and then x is equal to 20. And then you would divide by 8. So if x equals 20, then here's what I know. Measure of angle A is equal to 20. Measure of angle B, okay, let's substitute that 20 back in. Take the 20, put it back in. 2 times 20 minus 10. So that's 40 minus 10, which is equal to 30 degrees. And measure of angle C, you can plug that back in here. That's going to be 5 times 20 plus 30. 5 times 20 is 100. 100 plus 30 is 130. And those are the measures of the angles of the triangle. So you can see we used a lot of different concepts here today, all review from some geometry. And you just have to use the rules. So think about what parallel lines mean, similar triangles with equal angles and proportional sides, and then of course our triangle sum theorem.